From the plush studios of South Studios of Way Happy, this is Mr. Meyer and 8-4 general form of conics. Now, this is where it's going to get a little crazy. Not only do you have to know all of your shapes, but now you're required to, let's do a little magic with them. Like right now, here in this example, you notice I don't even know what shape it is. There's little hints, by the way, but we don't know what shape it is. So that's the bad news. So I'm going to go ahead and try to do this guy. First thing I would do, like always, every shape, get the x squareds. If there's x squareds, get the x's together. If there's y squareds, get the y's together. And if there's anyone who is neither an x or a y, get them out of here because we don't need them. Now, we got to complete the square so we can see where the center of this shape is. And I'm going to have to pull out a 2, and I will be here. Now I'll have to pull out a 3, and I will be here. What is that? 8. And now I can actually complete the square. Be super careful when you complete the square on these. Half the middle number is 3, squared is 9. I'm going to add 9, but notice I'm going to add 18 to this side because that 9 got multiplied by that 2. I'm going to take half the middle number is 4, squared is 16. I'm going to add 16, but again, 3 is multiplying that 16. So I'm really adding to this side. What is that? 40, 30 and 18, 48. So that's like 50, 66. So it actually ends up just being 6. And so what am I left with? X plus 3 squared, there's a 2 out front, plus 3 y minus 4 squared equals 6. And then we divide them all by 6 because it's obviously not a circle because the 2 r's in there. It's not a parabola because they both have squareds. And so finally, all said and done, it's x plus 3 squared over 3 plus y minus 4 squared over 2 is equal to 1. Now we know how to graph this, right? You go out and you graph this. You go left 3, you go up 4, and you go in the x direction root 3, the y direction root 2, and you graph your shape. And just so you know, there's another way that people like to do this. They go, all right, here's your graph. They read the transformation first. They go, all right, it's x is negative 3. So they go like this. And they go, y is 4, 1, 2, 3, 4. And they go like this. And they go, all right, just pretend that no longer are we talking about x and y, but we'll just kind of call this x prime and y prime. And now you don't have to worry about it. You can say that it's x prime over 3, well, I guess x prime squared, plus y prime squared over 2 equals 1. And what that'll do is then you don't have to worry about the transformation anymore. You can just do it off that new set of axes. So again, in the x direction, I would go root 3, which is like a little more than 1. And in the y direction, I go root 2, a little more than 1. This was our center, and here's my elliptical shape. Now, you probably think that's pretty silly. And to be honest, it kind of is. But the reason I talk about it is because we're going to have to do that if this next case comes up. If there is ever a B term or an XY term, I should say, life has gotten crazy because that means the conic that you're going to graph is rotated some degrees, and that, or some radians if you like, and that is challenging. So you have to rotate your axes those many degrees so you can just graph off of that. So that is the big trick you're going to run into in this. So how do we find that rotation? Well, first thing you do is you notice that there's an XY term. That's going to get you the rotation. Remember, you still have A, B, C. Here's the formula that tells you how much of the rotation is. So if you have a B term, that's going to get you the answer for the rotation. So you definitely want to write that down. We are going to then substitute those values in. Do that on the last example. We're going to use these highlighted yellow equations as our new equations for the axis of rotation. So once we figure out the angle, we'll plug it into cosine and sine, and that will help us get our new axes or our new values to graph on this rotated axis. So that's going to be kind of crazy. And then right here, if you were curious what shape it was, well, that's called the discriminant test. And the discriminant test can always at least tell you what shape it's going to be. And it's called the discriminant from the quadratic formula. The thing under the radical is the discriminant. Well, here it tells you which one it is. And kind of a neat thing, I have a hard time remembering this part right here. I can remember that if it's 0, it's a parabola because there's only one squared. But I couldn't remember the other ones. And what I would do for the other ones is this. If it is greater than 0, think of this as your center, right, of your graph. That kind of looks like a hyperbola. So if you draw, that and that look like a hyperbola. And we call this the Alyssa rule. Alyssa had noticed that if it looked like greater than 0, she knew it was a hyperbola because she visioned that. And look right here. If you have this one, this is less than 0. Think of that 0 as your center. That shape would go around. That's an ellipse. And so the Alyssa rule says that I will do greater than 0, it looks like a hyperbola. Less than 0, it looks like an ellipse. And then otherwise, it's a parabola if it equals 0. So look at this problem here. It says, what type of graph is it? Well, there's your A. There's your B term. That means we're in trouble. And here's your C term. Okay, what kind of graph is it? Well, I'm going to do B squared minus 4AC. So I'm going to do B squared, which is 36, minus 4. A is 1. C is 2. Make sure you always get those. Maybe sometimes they mix them up in order. A is always in front of x squared. B is always in front of xy. C is always in front of y squared. And what do I have? 36 minus 8, which all I can tell you is greater than 0. And so therefore I can tell that that is a hyperbola. And there you go. I know that that's a hyperbola. All right, let me ask you a question, and we'll come back and do some crazy stuff. All right, nice work. Now let's talk about this next part where I take the example that we were working on above before the break, and I want to rewrite it so I can put it in as Ashley Rose says, a grapher, one of their favorite devices. You can use Desmos, you could use whatever. Okay, not Desmos, because Desmos is too easy. You just type it in, it's going to graph it for you perfectly, and you're going to be like, wow, that's great. So let's not use Desmos. Let's try to put it into our graphing calculator. Now, the scary part here is this. When you have to put that into your graphing calculator, your graphing calculator needs this equation to say y equals. And you're like, what? Y equals? Usually that's not a big deal, right? You usually keep y on one side and everybody else to the other side. And that would be great. But we have a couple of y's here, right? I see a y in the 6xy. I see one in the 2y squared. Oh no, it's a quadratic. And how the heck are you ever going to isolate a quadratic? Psst, the quadratic formula. Yeah, but this is going to look insane, right? Well, first let's write it like a quadratic formula. So again, we care about the y variable. So we're going to go 2y squared. And then we need the y term. Well, what is the y term? It's going to be plus. And then what do we have? 6x plus 40. And that's the y term. And so we've taken care of this, this, and this. And now who is not a y term? Who is a constant in this case? That is the rest. That is x squared minus 10x plus 200. So remember, quadratic formula, you always want something to be equal to 0, which it is. And look at this. The highlighted yellow is your A value. The highlighted blue is your B value. And the highlighted green, believe it or not, is your C value. So what goes in your grapher? Well, instead of x is equal to, y is equal to the opposite of B plus or minus the square root. I guess I'll do plus first because it's got to go in a grapher, so I'll call this y1 plus the square root of b squared minus 4. A is 2. C is x squared minus 10x plus 200 all over 2a 4. Crazy. Now, the cool thing about putting it in a grapher is you don't have to, oh, that was a squared there, huh? B squared. You don't have to FOIL this all out and combine like, heck no. Let the calculator do the work. This is what's going to go in Y1. And then guess what? You're going to do the exact same thing in Y2, but you're going to change that sign in the middle. So you'll put -6, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So there you go. That's what you would put in your grapher. And your calculator then will graph y1, it'll graph y2, and you will get this rotated hyperbola. And you'll say, wow, that was awesome. That's what you would do on a calculator test. Don't forget that. Now, what about a non-calculator test? In fact, let's answer the question and then I'll come back and do that last example because it's going to cause some crying. All right, great confidence there in showing me that you hit continue to move on. And I have now, this is the third take on this section, and there's just not enough time to finish this problem, but we're going to start it and then we're going to finish it in class. So here we go. Notice the XY term. That right there is telling you that you're in trouble if you're not allowed to use a grapher or something, because you're going to have to graph this by hand. So there's the two things that I'm going to want to do right now. One, I'm going to want to find out what shape it is. So remember, this is A, this is B, and this is C. And so if I do that, if I go ahead and do the discriminant test, B squared minus 4AC, then that just means that it's, all right, that's kind of gross, negative 6 root 3 squared minus 4, A is 7, and C is 13. That's going to be 36 times 3. Was that 36 and 3? 108 minus, what is this, 28 times 13. Well, that's bigger than 28 times 10, which would be 280. So I know this is going to be a negative number. And a negative number means that you are less than 0, which according to the ELISA test, that means we are doing an ellipse. So there you go. We know it's an ellipse. So that's nice to know. We also know it's a rotated ellipse. And how do you find the rotation? Well, we breezed over that, right? You have the cotangent of twice an angle is equal to A minus C over B. That's how you solve that for the angle. That'll tell you how much this ellipse is rotated. So first thing I'm going to do is 7 minus 13 all over negative 6 root 3, which is negative 6 over negative 6 root 3, which is 1 over root 3. All right, you can do the cotangent of that, or if you want, let's flip it. A lot of people like to do the tangent of root 3 over 1. All right, fold down your fingers, figure out, really what you're going to do is arctan this other side. So you're going to tell me what is the arctan of root 3. So again, you're going to get on your fingers and you're going to fold down until you have root 3, which to me looks like 60 degrees. So 2 theta is 60 degrees, which means that theta is 30 degrees. This has a rotation of 30 degrees. So what does that mean? Well, remember, here's our XY axis, right? You have X and Y. So I guess I should have said that the correct way, but there's X and there's Y. What I'm going to do is rotate our axes like we did up in the very beginning when it didn't make sense. Here it might not make much sense either, but I'm going to rotate about 30 degrees. So this, I hate that when I can't go through the origin. I think I could draw a little better. There we go. That's a little better. Let's call this 30 degrees. That is our new x-axis, so we'll call it x prime. And this is our new y-axis, so we will call that y prime. And that's the one we're going to graph off of once we get rid of this xy term. And how do we get rid of that xy term? Well, that's, fun. You have x equals formula, y equals, it's got primes and cosines in it, and we're going to do that in class. And then what we do is once we find these, if you want to try on your own, give it a shot. Once you find those, so use the highlighted formulas, figure out what, the angle is 30 degrees, figure out what x and y are, substitute it into this one, and then get rid of all the xy terms, FOIL it out in a big long mess, and then you'll finally have a graph that you'll be able to put on those blue axes, and you'll get to see the graphed equation. So we will do that in class. Thank you for working, and I'll see you tomorrow. Stay happy.